That's good. Got a nice big swallow on the microphone. So freaking creepy. You didn't get it already, did you? No. Oh, good. Oh, my God. Like, dude. The tip, I have a tip for you. Can you manipulate, that's S of n, can you manipulate S of n plus 1 into something that's obviously divisible by 3? And you have to, there's a weird, you got to finagle it. I think we probably all have the base case. You need to write this in terms of the S of n. That's the tip. So fit S of n into there. It's going to require a little weird accounting. It's almost an accounting problem in a way. Making any progress. Yeah.
I'm trying to think how to rewrite these.
Yeah. Yeah. Indeed. Okay, you're doing. How you doing?
I put it into that other form that we have where you said you can say like whatever's divisible by 3 equals 3k, because then I was thinking if I have it in that form I can multiply both sides by the n plus 1.
So where does that get you?
Not far.
Yeah, because that trick was pretty unique to the last one.
Okay.
So what I would say is, you agree that's the next thing we got to show is divisible by 3?
Yeah.
How does that relate to the original thing that's divisible by 3? So in this one, try to rewrite that expression in terms of the original 10 to the n plus 10, or 10 to the n plus 1 plus 10 to the n plus 1.
Well, I have that here where I left it as the n plus 1 plus 1. So that's still technically n, you're just substituting it with...
Yes, definitely. But now take that expression, which is 10 to the n plus 2. Actually, this is almost kind of close, except the thing that I would have out, maybe think factoring. Because I just want to point something out to y'all here. And I just kind of, you can almost kind of factor a 10 out of this and this. Not that, though. But what if that were something else? And then, I can't tell. I just like, there's a trick, and it's like, but I would say that think about how that relates to this. And I'll put even more tips on there. Let me see.
Am I getting anywhere here?
I don't think so. Yeah, that's all right. Try this tip. But so the only problem is, Cormac, is you're falling back on just this, and that we don't know anything about that. This is the thing I know about. And let me say even more. If I could rewrite this like this, and this were divisible by 3, that's already divisible by 3. If this is a multiple of 3, and this were for some reason a multiple of 3, then the whole thing would be divisible by 3. That's the last hint I can possibly give without filling in them damn boxes. And it's good to suffer on this. This is a good suffering. Because you'll feel really good when you get it. No. Just give me it. Yes. Yes. Yeah, but you need that plus 1 inside there, right? So what if you put it in here? What if you move that in there, put the parenthesis, and then get this back to where it needs to be? What do you need to put on the outside? Yes.
-9?
Factor something. Put something here. Here's another tip. Put a number here that makes this almost look like, well, that makes this, so this whole thing is going to turn into some multiple of this. I want this thing inside here. I want that to become that, but what do you have to multiply by? And then what do you have to balance? What can I almost factor out? 10. But I can't factor 10 out of 1. But I could factor 10 out of what? 10. So what if I put, what if I did that? What would need to be here to balance and make sure it's the same thing? Yeah. Good work, Camilla. Yeah, that's great work. That's great work. Yeah. It's cool.
Yeah.
It's painful. Do you see the rewrite? Take this expression, pull the 1 out to the side. So kind of what I did was I like pulled this 1 out here, added a 10 in here, but then subtracted 10 off out here as the balancing. And now this, it's got this companion, it's got that -9. Now I can factor the 10 out. This is a multiple of 3. This is a multiple of 3. Multiples of 3 combine with multiples of 3s to give you multiples of 3. Divisible by 3, divisible by 3. So this whole dang thing then is divisible by 3, but only because we know this is. Be on the lookout for such a trick in the next 7 days, or next Tuesday when you start the homework. Be on the lookout for this. Go back and watch the recording. So, Penelope, how are you feeling about that? Are you sure?
Well, I get.
Do you want me to go through it?
No, I get the outside
Okay.
part, like subtracting the 9, but I guess I'm confused on why we're multiplying it by 10. Like the whole.
Gotcha. So let me do the forward here. I think this might make it. Let me actually do the proof now that you've seen the trick. So we're going to assume this. We're assuming that this thing is divisible by 3. So now consider the by. Have fun with your laundry. Really beats being in class. At least you can do whatever you want with your mind. I guess you can do that now. So S of n plus 1 looks like this. And I know that this thing's divisible by 3. So Penelope, what I'm going to do is take this and try to write it in terms of this. So notice that 10 to the n plus 2 plus 10 to the n plus 1 plus 1 equals, now here's what I want to do. I kind of want to factor a 10 out of both these to get them to look like these, but I can't because of that guy. So what I do is that say that this is this plus this, and then I'm going to basically just put a 10 there and balance with a -9. So I rewrote the 1 as plus 10 and minus 9.
Okay, so basically, oh, okay.
Now you see it.
Yes.
Yes. And so then this is 10 times the thing we know is divisible by 3. And that's where does that make sense? Cool. Is everybody cool with this? Abraham, you're good. And Kayla, you feel okay about this? Okay, awesome. And it's kind of one of those things you have to see. But it was definitely better to suffer on it before you saw it, because it makes it just stick better in the brain. So now this equals 10 times a multiple of 3 minus a multiple of 3. And that sure sounds like a multiple of 3. And that's kind of loose and sloppy.
This is kind of like maybe more than needs to be included for the multiple of 3 step to like formalize that. Could you say that like?
I like it. Make me do it.
Yeah. Well,
No,
like
make me do it.
the multiple of 3 would be equal to 0 mod 3.
Yes. And actually, I think I got a better route. How about this? You'll like this. You're right. Christian's calling me on it because that was bullshit what I was writing.
Did you do that route of like combining mods at the same base?
Yes.
And then that would just get you to 0 mod 3.
Yes. Yes, exactly. But I feel like I might have a better out for us. So this is equal to 10 times 3 m for some m minus 3 times 3 for some m. And this is because S sub n is true. Does that sound okay so far? And now I can take that is equal to 3 times 10m minus 3. I think this might be a little just simpler, just less writing. And that's what I'm feeling like right now. So we see that thing is a multiple of 3. And this is literally, since I'll be super precise since you called upon it. You summoned the Lord of Precision. Since 10 MT3 is an integer, because the integers are closed under all sorts of shit, then by definition of divisibility, yes. By def, Sn plus 1 holds. Does that sound better? Thank you. Somebody's got to hold my feet to the fire. And it's you guys. So don't let me get away with that shit I was pulling before. Because I wouldn't let you. Don't let me get away with stuff you can't get away with. How do we feel? Yeah?
I think the thing that I struggle with proofs by induction is it feels like every single one of them is so different. Like,
it's true.
None of them are remotely the same.
It kind of, sometimes it does. I got one more. Let's take a look at it. We've got 10 minutes. Because I thought the more we do, the better you'll feel. So this looks fun. And you'll like this, Sophie. Kind of a similar trick.
You said kind of similar about the last one.
Did I? Did I? Oh, what a chump. Man, thanks for calling me on that too. Jeez, what a bum. All right, so prove 17 divides 2 to the n times 3 to the 2n minus 1 for all n, for all natural n. So starting at 1. I won't even look at my notes and try to remember what I did in the past. Yes, ma'am. Did 3 to the 2n is what I did. I meant to say this if I didn't. Yes, ma'am. Yes, yeah, yes. Yeah, Camilla, this is, no, this is the times and then the minus 1. Thank you. Yeah, good to check. Base case cake. I hope.
So then is the for all n in natural numbers, is that technically our n naught?
Yes. So our n naught is going to be 1. Yes, ma'am. So n is equal to 1, 2, 3. On up. So yeah, your base case is going to be that lovely 17. Hopefully you're getting 17. Oh, Camila, did you like work it out with the base case and go like, this isn't divisible by 17? Or were you just checking before you even started?
No, I was just checking.
Okay, cool. That's smart. You might want to rewrite the inductive assumption or the inductive hypothesis in this way. That's a great way to take this and put it into something usable, like I kind of did over there when I replaced that with 3m. This can help you a lot for some unknown m. We don't know what that is, and it's a natural. And again, you want to somehow construct S sub n in here, or this expression needs to be constructed in S sub n plus 1. Oh, okay. This is a lot like the last one. This is a lot like it. I'll show you the move since we're coming up on it. Okay, yeah, some folks still working. I'll just put this up here if you're interested in seeing, and you can check out the recording later, whatever you need. But I can pull this 18 out of here pretty nicely, but I can't pull it out of here. So watch what happens. I'm going to take 2 times 3 squared, and inside this bracket, I'm going to write my thing that I know is divisible by 17. So I put, 3 to the 2. So I took this statement, I factored out a 2 times 3 squared from here, and now I've got this. But this isn't the same as the thing that I had. Right now, since I put that -1 in there to make it look like my buddy that I know is divisible by 17, this is divisible by 17, but it's not what I started with. So notice that when I put this -1 in here, I essentially subtracted 18. But that -18 and whatever's out here need to somehow combine to a -1, so I'm just going to put a +17 out here. And now, this is divisible by 17. That sure the hell is divisible by 17. And so the whole damn thing is divisible by 17. So kind of the same, a little harder. Kayla, do you have a question? I feel like you do.
Well, I was just, so if we get to the point where we have like the +17, I'm trying to like.
Oh, yeah.
So we have 3 times 3 there, which is divisible by 3.
Oh, gotcha. Cool. Gotcha. So once I get to here, I would say, so we already know that this is 17m, because I assumed that over there. So then this is equal to 2 times 3 squared times 17m plus 17. And now I can pull the 17 out in front. And I have it's equal to a multiple of 17. Then I think that's what you're trying to do. Is that good?
This is kind of a goofy question, but like, do you usually, in the proof, do you usually show that your n+1 case can be worked back into like your inductive assumption, or do you? Like,
well, there's two. Yeah.
I was trying to like work it back from like the assumption out to
yeah.
n+1, and you can do that, but it's clunky and like.
Yes. Sometimes that's the right answer. Sometimes, usually what it's whatever's easiest. Yeah. And sometimes it's one and sometimes it's the other.
Okay.
Yeah. It's just experience of doing it. And sometimes you'll fuck it up and you'll do it again. Yep.